All right, guys, welcome back from Christmas break. We are into January, and we are going to start a week of strange little topics that all fit together because they relate to trig. So the first is vectors. A scalar is a quantity that has magnitude only. For example, time or weight, or it has one label only. Okay? A vector is a quantity that has both magnitude and direction. So I'm going to go 30 miles an hour north, or I am going to have a force of 6 newtons in this direction, or whatever. So the magnitude of a vector relates to its length when you draw it, and it's called a directed line segment, meaning it ends, it's not a line that goes forever, but it ends at the tip of the arrow here. So it has direction and it ends at the end of the arrow. So it's called a directed line segment. The direction of the vector is the direction that the angle shows between the positive x-axis and the vector. So we're going to draw some of those. First of all, a vector can be represented geographically using a directed line segment. The P here is the initial point, also called the tail, and the Q, because the arrow goes that direction, is the terminal point, or where it ends, and it's called the tip. Okay, so this is the tail, and this is the tip. Vectors are denoted using the arrow notation. So the vector PQ that's up here can be named PQ, and sometimes you'll see a single-sided arrow like that. Sometimes people write a double, it doesn't matter. Or P, and that should have the little arrow too, it's hard to see right there, or a bold-faced letter. All right, we're not going to do a whole lot with this, but just so you've seen this, parallel vectors are any two vectors that have the same or opposite directions, but not necessarily the same magnitude. Okay, so they can go the same way or opposite directions, but their slope is the same. Okay, that's the deal. Their slope is the same. Equivalent vectors mean they're going the same magnitude and the same direction. So you could have two identical vectors, same magnitude, same direction. You know, maybe one started at the origin, one started to the right of the origin. All right, opposite vectors have the same magnitude but opposite directions. So if one's going this way, okay, the other one would be the same length, but the arrow would be on the other end. So if this is vector A, this is called the opposite of A. So they want us to just fill in what these are. So we have A and E. So A went up 1 and left 2, and E went down 1 and right 2. Those are the same length, same slope, same tilt, but they're going in opposite directions. So those are opposite vectors. I goes up 2, 3, 4, 5, 6 and over 2, and F goes up 1, 2, 3, 4, 5, 6 and over 2. Those are equivalent. Is that what it was called? Yeah, they call it equivalent vectors. D and E, D goes down 2 and over 1, 2, 3, 4, and E goes down 1 and over 2. Now, those are the same slope, okay? They are not the same length, but they are parallel vectors because they have the same slope. B and G, let's see, B went down 1, 2, 3, 4, and 1, 2, 3, 4 over, and G went 1, 2, 3, 4, 1, 2, 3, 4 over. They are the same length, but they're not going the same direction, so they're not called equivalent. Let's see, are they opposite? No, because they're not have opposites have to have opposite direction, and these are going at an angle to each other. So these are none. C and H. H is down 3 and over 1, and C is up 3 and back 1. So they are in exactly opposite directions again, and the same length. If you put them end to end, they would be going exactly in the opposite direction. All right, now we're going to get to what is going to help us learn to add vectors eventually. But for today, the start of this, we're just going to draw them, and then we're going to find their components. All right, so any angle given without a direction is going to be from the positive x-axis. Okay, so this vector says, that's just our positive x-axis, it's not the vector. The vector is, vector v is 60 pounds of force at a 125-degree angle. So that goes past 90 over here somewhere, and it starts here and ends here, and it has 60 pounds of force, and the angle off the positive x-axis is 125 degrees, and we can label it V. W is a vector that goes 55 miles an hour at a bearing of, now, we did bearings right before Christmas. We have, or a couple weeks before Christmas, in the Law of Sines and Cosines chapter. Off of south, this one goes 45 towards the east. That means this is 45 degrees, but we measure everything off the positive x-axis. Well, this is also 45, but it's actually in a negative direction. So you could call this a negative 45-degree angle, or you could say it went all the way around this way, which would be 315-degree angle. And its length, or magnitude, is 55 miles per hour from its tip to tail here. And I think that's everything. Oh, W, we're supposed to label it W. 30 miles an hour at, this is off of north, 40 degrees to the west. So off of north, if we go another 40 degrees over towards the west, we need to mention off of the x-axis what this would be called. So we're going to say 90 plus 40 is 130 degrees. And we're going to label it as 30 meters long and R. And this 150 yards at a 20 degree to the horizon. This one is just a 20-degree angle in here. And from here to here is 150 yards. And it's called T. All right. In order to be able to add vectors and work with them, we're going to need to break them down into their horizontal, okay, or X components, and their vertical or Y components. So this is just like an XY ordered pair, but when it's components of a vector, they use these parentheses. So to do that, if we had this picture, Jamel pulls on the ends of a rope tied to a dinghy with a force of 90 newtons at an angle of 60 with the horizon, or with the horizontal. So to find x, we have adjacent over hypotenuse. So you would say the cosine of 60 equals x over 50, or 50 times the cosine of 60 would give you that x. If you're trying to do y, you would have y equal, or I'm sorry, the sine of 60 equals opposite over hypotenuse. Multiply that over here and you get 50 sine of 60 would give you the y coordinate. So this is, as long as you measure always the angle, as long as you use the angle off the positive x-axis, okay, wherever you are in the quadrants, you give the angle off the positive x-axis, then the magnitude, the magnitude times the cosine of the angle will give you the x, and the magnitude times the sine of the angle will give you the y components. Okay, so that's the rule we're going to use to do all of these. Now, this one you could do as a decimal or exact. If we went to the, they just did as a decimal. So they just put their calculator in degree mode and typed in 50 cosine of 60. Cosine of 60 is a half, so that was 25. And then 50 sine of 60 was 43.3. And as long as you do the angle off the positive x-axis, it will take care of the sines as well. So this is saying the force generated by him pulling 50 newtons at an angle of 60 degrees is a horizontal force of 25 newtons and a vertical force equal to 43 newtons. Okay? So we're going to go back. This is the rule. You take the length of the vector times the cosine, the magnitude, times the cosine of the angle to get the first one, and the magnitude times the sine of the angle to get the second one. And that's how we're going to do every single one of these. But that's why we're going to use these angles that I helped write off of the positive x-axis. So for this one, I don't have my calculator on yet. We're just going to type 60 cosine of 125 and 60 sine of 125. And then we're going to write it in components, making sure we're in degree mode, which I am in degrees, and I already forgot what it was. 60 cosine 125 and 60 sine 125. Okay, now it came out negative positive. Does that make sense? Negative 34.4, 49.1. I hope it does, because we went left and up to find the tip of that vector, right? So there's a certain amount of force acting to the left and up when you're at a 125 degree angle. So this one, because it's actually pulling down into the fourth quadrant, should turn out positive negative. Okay? For this one, you can use either the 315 or the negative 45. I'm just going to use the negative 45. So the magnitude times the cosine and the magnitude times the sine. Now, if you know anything about cosine and sine of 45, they should be the same, but the first one's going to be positive and the second one's going to be negative. I already forgot. 55 cosine 45, negative 45. If you don't remember the negative, it won't turn out negative for the sine here. And it's going down, so we want it to be negative. All right, so 38.9 to the right, and then negative 38.9 down. What we're going to need is to find these components so that we can then add two vectors together tomorrow. All right, so this one had a 40 degree angle off of north towards the west. So that made it 130 off the positive x-axis. So 30 cosine of 130, 30 sine of 130 is what we should be typing. And you'll get an answer. This one is 20 degrees off of the positive x-axis, so it's 150 cosine of 20, 150 sine of 20. And I'll go back and fill those in, but it's that easy. There are 3 of these here for you to draw. This is off of north 43 to the east. I should have made that dotted. So off of north 45 to the east would also be off the x-axis 45. And this one is 60 meters long. And you can call it R. So you're just going to do 60 cosine of 45, 60 sine of 45. This one you're going to do 100 cosine of 120, 100 sine of 120. You're also supposed to draw it though. It says Nadia's pulling a tarp with 25 pounds of force along the tarp if the tarp makes an angle of 50 degrees with the ground. Okay, so she's pulling it this way with 25 pounds of force, and it's making a 50-degree angle with the ground. Find the horizontal and vertical. So you're going to do 25 cosine of 50, 25 sine of 50. All right. Then one more thing before I finish this, I want you to start looking at and thinking about when you put these in the coordinate plane. There are some delta math questions on this today. It says when you find the component form of a vector connecting 2 ordered pairs, okay, what you do is subtract where it ended from where it started. So x2 minus x1 and y2 minus y1. Now, honestly, I don't think of it that way. I think of what direction is it going, but we'll talk you through that in a second. The second thing is that if you know the component form, which is what we were finding here, given an ordered pair with regular parentheses, we were finding the component form, okay, how much x it was pulling and how much y. The component form, and that's why I had the little parentheses, the little bracket things there. Once you have that form, okay, when you have this form, well, they didn't. Oh, here, component form AB. There we go. When you have it in component form, then you just do Pythagorean theorem to find the length of the vector. So anytime they ask for magnitude, I want you to think Pythagorean theorem. Okay? So this one says we start with an initial point of 2, -3, so they plotted it here, and a terminal point of -4, 2. They plotted it here, and it was going from there to here. So what you're supposed to do is take the second one and subtract the first. So -4 minus 2 is -6, and 2 minus -3 is +5. I usually just look at it and say, well, it went from 2 down to -4, so therefore it went to the left, 6, and it went from -3 up to 2, so it went up +5. Same difference. I just, instead of working backwards and subtracting, I just think about where it's going in which direction. Either way. If you're going to subtract, you have to do the second one first. Then to find the magnitude, well, we know it went left and up. So we're just going to do Pythagorean theorem. So we get 36 plus 25 is 61. The square root of 61 is the magnitude. That's it. So there's 3 of them here. You're going to do the components. It does say the vector's going from A to B. Maybe we'll change one of them. What if they said B to A? Okay, just so keep you on your feet here. A to B would be 52 minus 12, or 12 up to 52 is 40. And 33 minus 41 is -9. 8, just kidding. Or if you went from 41 down to 33, you subtracted 8. So then we need to do the magnitude. So we have, what is that, 1600 plus 64. The square root of 1664 is the magnitude, which is 40.8. All right. On this one, if we're doing A to B again, if you're going negative 15 to 7, you went up 22. If you go from 0 down to 19, you're going to go negative 19. Otherwise, it's negative 19 minus 0, because remember, you go backwards when you're subtracting. Then Pythagorean theorem will give you the magnitude. If you don't want to use parentheses, just leave the negative off, because that's all that happens when you square it. I got 29.1. And this one, just for fun, I was going to say, what if it said BA? Okay. If it said to do BA, you would be going this way. From negative 1 up to here would be 3. Because you would say 2 minus negative 1. You'd start with A and go to here. If you were going from 3 to 4, you went up 1. Or when you're doing BA, remember you start at A and subtract B. Okay. If you went the other direction, if you actually did AB, the signs would change as all. So it would be negative 3, negative 1. Now, the length of these is the same. Okay, the magnitude of either one of those is just 3 squared plus 1 squared, because when you square negatives, they become positive. So it's square root of 10 or 3 point something. 3.16 or 3.2. Okay, so that's some of the things you might have to do in delta math today. Day 1 on vectors.